Okay, hi everyone. Thank you for coming today. I know you have an exciting week next week, so thanks for making it. Today I have the pleasure, or we have the pleasure of having Professor Claudio Barbieri Cunha presenting our seminar. Claudio is a great friend, and he is our Fulbright chair for UC Davis. So you have been visiting us since August, and he will be here with us until January. Well, technically December, and then some travel until January. Claudio is a professor in the Department of Transportation Engineering at the University of Sao Paulo. He is a renowned expert on operational research with applications to transportation. And we have been interacting in the area of freight and logistics for a long time, but he's not as biased toward just one field as I am. So he also works in transit and many other fields. So today he's going to be presenting on network design for transit. And so we're all yours, Claudio. Thank you for being here.
So thank you very much. It's a pleasure and an honor to be here. I also asked them to take a picture of me so that my friends can be jealous for me to present in such a important audience at ITS UC Davis. Basically, I'm talking about transit network design. Okay, some introduction and some. I think it doesn't work here. An introduction and some aspects. Okay. Oh. Side. You're right. This is okay. So basically, a brief introduction. As Miguel has said, I'm a professor at the University of São Paulo in São Paulo, Brazil. I have all my degrees in civil and transportation engineering, and I'm here on a Fulbright Distinguished Chair award. Okay. Brief outline of my presentation. I'm going to tell you briefly what is the transit network design problem and its relation to the more general transit planning problem, some approach for this problem. I'm also discussing, going into details of the transit network design and frequency setting. Frequency setting problem. I'm going to describe one of possible solution algorithm for this, a genetic algorithm. I'm going to show you the results from some benchmark instances, and I think the most important part of my talk are some takeaways. Okay, some opportunities of future research on the topic. So basically, what comprises the transit network design problem? It's to determine a set of bus lines or routes like this, and for each route, the detailed itinerary, the stops, okay, the vehicle types that are being used, and the frequencies. This problem has other denominations, as you can see here: transit route network, design problem, urban transit, or as in England they say, public transport instead of transit. Okay. This is an example of a transit network for the city of Davis, 16 routes, 50 buses, if I'm not mistaken, and some street pattern that the city has been built or has been developing or involving that reduce the candidate street segments, because all those internal streets that are not linked to the major roads are not possibly candidates for networks. Okay. Okay. Another example, details of one bus route, the one that I usually take to go home. Okay, I'm not driving most of the time, I'm riding bus. I have free fare because I'm already a senior guy. Okay, so either I'm biking or I'm riding buses, and I do it also as an experience. Okay, and also it may include the timetable, but I would say that timetable is not formally a part of the transit network design problem. So basically, what does the transit network planning involves? It involves what I said, the network design, the setting of frequencies, which means intervals, okay? Vehicles per hour in different periods of the day. It doesn't happen here in Davis, it doesn't happen in Sacramento, but in many places of the world, you have peak hours in which the frequencies are higher. In our university, we have some routes that connect the university to a subway stations, and we have buses running every 7 minutes. 3 different routes that connect the university to the subway stations every 7 minutes during peak hours. When they are not peak hours, students are not coming or going back, it's every 50 minutes. Okay. It also involves the timetabling, the overall network planning problem, and also the schedule of vehicles and crews. Okay. This is a more detailed view of the overall problem, which includes all those problems that I had discussed before, also inputs and outputs, and also something else that did not appear that, which is real-time control, something that would allow the bus to be dispatched timely and according to changes in demands and changing things that might happen. Okay. From an optimization point of view, this problem has 2 different objectives. We are concerned about the users, how to minimize travel times, how to minimize waiting times, how to minimize transfers. For instance, if I want to come from home to here, ITS, I have to make at least 1 transfer, which is always inconvenient, despite the bus is being always on time. So I don't say, oh, is my bus going to be late and I'm gonna miss my transfer, especially if it runs every half an hour as it happens here. Okay, and also maximize direct trips. On the other hand, you have to take into account that for the operators, we have to minimize their costs. And in general, in the literature, these costs are related to the fleet, to the number of vehicles that are required, not always to the total distance that's traveled. Okay, so as you can observe, these 2 objectives are conflicting. If I want to improve level of service for users, for riders, I'm gonna have to be more vehicles, would have to be more frequent, so the cost will increase. Okay, and this is also from the optimization point of view, a combinatorial optimization problem, in which the solution space is typically very, very large. Okay? For you to have an idea, in San Francisco, we have about 3,000 stops. In London's Transport for London, 19,000, 12,000 in Paris. In the city where I come from, São Paulo, 19,100 stops, only the city of São Paulo. In Shenzhen, I tried to find, I could not find the number of stops. If someone has this answer, please write to me later so that I can improve my presentation and not do a shame with Asia, okay? Shenzhen is a very important city in terms of buses, very big city. All buses are electrified, so it's a very important case for all of us to learn more, okay? And basically, imagine in the case of San Francisco, you designing routes here, starting points, ending points, itineraries, stops, and etc. Also frequency. So from the mathematical point of view, this is a very complex problem. Approach for the transit network design problem. First approach is a more simplified approach. Forget about optimization. Let's do continuous approximation approach, in which continuous approximations will derive some expressions that would allow us to define line spacing, stop spacing, and line frequency. Sometimes you have to make some assumptions in which demand is uniformly distributed along the service area, which does not happen in many cases, or continuous function of over geographical space. And when we speak, when we are talk about continuous approximation, what name comes to your mind? An expert from University of California system. Carlos D'Aganzo. So Professor Carlos D'Aganzo from UC Berkeley, he has developed a very sophisticated continuous approximation for transit and also for freight, etc., routing, etc., in which he was trying to decide what would be the best network structure, geometric layout for a square region. I have not seen anything like this, but okay, this is good for theory, okay? This is good for us to understand the concepts, okay? And he was trying to combine grid buses going north, south, or east, west, or something like that, with hub and spoke structures, okay? For different trip generation rates. And his results showed that hub and spoke networks are more attractive when infrastructure, especially road infrastructure, is expensive. BRTs are good with cities with medium to high densities. I think everyone knows what BRT are. Okay, if you don't, raise your hand. I'm gonna explain briefly to you. Better than metro, if there is enough space in the streets. Okay. This approach has been applied to different cities to generate new lines in Barcelona, okay, from one outer, or to determine the optimal location of bus stops in the city of Santiago, Chile. Discrete optimization for this problem. In general, mathematical formulations are difficult to be solved. Exact methods are difficult to solve this problem because these problems are very big, very large, too many combinations. So only small instances, sometimes a single line, I have to define just a single line. This is not really very realistic. Sorry for that. Perfect. And usually we employ sequential approaches in which different parts of the problem are solved one after the other. So the network design on a strategic base, the lines, types of vehicles, and stop space. Then on a tactical level, the frequency setting and the required fit. Some sort of interaction between the two levels, and each stage is solved by some not exact methods, heuristic methods. Okay? In general, meta heuristics are commonly used in special genetic algorithms. Other approaches involve, in general, population-based heuristics in which different solutions are generated and are dealt with simultaneously. So particle swarm optimization, ant colony optimization, bee colony. You know that people in optimization, they like to mimic the nature. So many methods to solve optimization problems are related to how, different species do their job in a good way. And hybrid methods as well. For a good reference on this problem, it's kind of a little bit outdated, but it provides a good view. We have this paper on transportation research, part B, from these authors. Ricardo Gissen is a good friend. He's from Pontificia Universidad Católica in Chile, and he was supervised by Professor Jaime Mamasari, who was here 2 weeks ago. Yes, correct. And Juan Carlos Muñoz is the Minister of Transportation in Chile. So he also has a PhD. So you have a future in PhD. You can become ministers and help solve problems. My lovely wife, who is here watching me and taking notes for me about my mistakes in English, how you said that word incorrectly, etc., always asks me, why don't you apply for being a Secretary of Transportation, for being a minister? I'm not competent for that, okay? And I wouldn't do that because you have a lot of, headaches. But anyway, this is good that people with good degree are in places that they can take good decisions. Basically, on the different papers that have been reviewed by these authors, you can see you have the objective, the constraints, and the solution method. In green are the objectives that are related to the users. In red are related to the operators, okay? And here you have the different types of approaches that they are doing. They have covered several papers. As you can see, most of the papers consider both objective, but not all of them. Most of the papers are based on heuristic methods to solve this problem, okay? So these three tables that I have done here give you an idea. As you can see also that genetic algorithm seems to be something that has been applied extensively to this problem, okay? Another good reference on this problem for the algorithm point of view is this work, okay, that describes some of the different methods that are used to solve the optimization problem related to this. And basically some comments on this. Part of the authors do not deal with the frequency setting part of the problem, which is not ideal because you are not properly dealing with the costs, operator costs, okay? Some authors do not really take much care about infeasibility of the network, which means that many OD pairs, people wanting to go from one place to the other, are not covered. The solution does not take this into account. Okay, so you can see here that these two nodes with the round blacks, they are not connected to the network. Okay. Also, demand allocation, which is a very important part. How your riders will select which route, which line they will select. They are solved, basically used a simplified approach of the shortest path method. So basically, everybody is gonna select the shortest path. And everyone who has worked with the traffic assignment knows that this is a very, simplified assumption on the problem, okay? And it's not very clear on how they determine the transfer points, where users transfer from one route to the other, especially when you have routes that share some common segments. And depending on where the rider transfers, it will affect occupation of the vehicles. So it will affect also fleet. This is part of the mathematical formulation. I'm not expected to explain this to you because it's not very useful, but in general, you have two different objective functions, one which might minimize the total cost for the users, and the other that minimize the total fleet as the operator costs. The typical constraints that the mathematical models have are those: minimum maximums headways for the different routes, vehicle capacities, route length, number of routes, and maximum fleet size. So let's jump to some sort of typical solution method for this problem: a genetic algorithm. Who in this room knows what a genetic algorithm is? Only you? Or you're asking me a question?
No, I know it. I'm the only one.
You are the only one?
I know a little bit about it.
Nobody knows about genetic algorithms.
It was super useful.
Wow, it surprises me. Okay. If you wanna learn more about genetic algorithms and things like that, please do let me know. I would be more than glad to offer you a session on these different topics. Thank goodness for me that many optimization problems are difficult to solve by exact methods, because everybody is looking for new methods, more efficient methods to solve these problems. And these methods are very creative, okay? different and very creative. And everyone wants to develop, to propose a new method. You know why? Because it's a way for you to get cited. Your H index increases. So I have a 100 H index. Why? Because I have a paper that has been, used by several people. Okay, that's how science is. Okay, part of science is. Anyway, GA was conceived by a professor from University of Michigan in 1975. It's based on Darwin's theory of evolution. The better the individual adapts to its environment, the greater its chance of survival and produce offspring. And so it's basically a population-based heuristic based on Darwin's book. Okay?
Thank God it's not a neural network.
No,
right?
no,
We've got some other nature thing. So.
It's simpler than that. Heuristics in general try to mimic how species or what people do to solve problems. Okay, in general. You try to use computer to do it very fast or in a clever or a guided manner. Okay, basically, the genetic algorithm that we have developed is a genetic algorithm that allows the two conflicting objectives to be cycled along the search. And the key components are this. We need a database of potential routes to be selected, some sort of function to assign demand and calculate frequency, to evaluate solution in terms of their feasibility, and also a mechanism for the feasibility check. Basically, you initialize a population, you sort the population, so the best individuals will have a more chance to mate, with other individuals. Individuals in the context of genetic algorithms are different solutions, and you mix the solutions, so you create new solutions that inherit characteristics of both individuals, and then you just iterate on this. Basically, what is the input data for applying any method, genetic algorithm or any other method for this problem? You need the network structures in terms of the bus, the stops and the road segments that you can use to connect the stops, and also the travel times of each link in the network. So this is another interesting point, because travel times are assumed to be deterministic. And everyone knows that in any big city, there is very little deterministic travel times on that. But the assumption is that they're deterministic. Please.
Thank you, it's very interesting. In what step do you assign the value to what solution is best? So the algorithm will do
You wanna, if understood correct, you wanna to know where, in what point of the algorithm I select the best solution, or in what point of the algorithm sorry, could you?
Not the best solution, that's the work of the algorithm, but you're assigning values to options.
I'm not really assigning values. I don't understand
The fitness function.
the fitness
Yes,
function.
the fitness function,
In what part of the algorithm do I calculate the fitness function?
yes.
In every iteration, once I do the crossover and the mutation, once I make solutions and I do some sort of disturbance of the solution, I calculate the fitness. And in our algorithm, the fitness are calculated one iteration. We are trying to minimize user costs, and the other solution we are trying to minimize operator costs.
So that list is your parameters, and then once you get a solution, it will check back to say which one is
Yes.
less time, and better in all of these categories.
Better in all of
Pass.
these categories.
Pass.
Yes.
Okay.
Yes. Okay. Thank you. So we also need an OD matrix. Okay. The amount of passengers between all OD nodes. This is just an idea of how those OD nodes is represented in a typical benchmark problem instance for this problem. And we also do a feasibility checking for the solution. So Nodes must be unique within route, so you're not doing circular routes or doing something that you come more than once to a stop or to some stops. Each node must be served by at least one route. All the pairs must be connected, and we allow up to 2 transfers. More than 2 transfers are declared in general in the literature as unsatisfied demand. Oh, it doesn't matter, the user is gonna be able to do 3 transfers, but in general, it's considered unsatisfied demand.
This makes a lot of sense, OD pairs. In the prior, you said a lot of people have used a continuous function.
A continuous approximation
Does
function.
that mean
So
the route
the
would stop
continu-
at any point?
Sorry, that would mean the bus would stop at any point. So basically, you have to decide the spacing between stops.
Is this usually a replica from a real system? Say
In the
Mexico
continuous
City with
approximation
stop
or
whatever.
this?
Which leads to better solutions, doing OD or continuous?
I give the question back to you. What do you think gives the better approximation?
No, but like the thing is like OD means like how many people arrive during the hour, but continuous means that they're gonna be arriving continuously during the hour.
No, it's not exactly that. I mean that, let's say that I am 1 mile distance from Memorial Union, okay? So the number of trips that are generated that will travel to Memorial Union will depend on distance, and you do a continuous approximation. So if you are 1.2 miles away from Memorial Union, you're gonna have a certain number of passengers per hour that wanna travel to Memorial Union. If you are 1.4 miles, you're gonna have a certain number of passengers required to travel on a given hour to Memorial Union. If you are 1.5 miles, so it's a continuous approximation that demand is distributed along the region. It doesn't matter if you're going south, north, east, west, and etc.
But it's not like a measured OD?
No. In this case, we are discussing something in which we have OD pairs from each part of the city, or it depends on how you discretize the area. This is something of one of my key takeaways, but how you discretize, you're gonna do it on a bus stop by bus stop basis. So probably you know people that are on each area, each bus stop, where they're going to. What's the number of passengers per hour that needs to travel?
That's where I was going. In
Yes.
that case, there's a limit, right? There's a number of routes, a number
Yes.
of nodes. The other case, which I was very impressed to see how to solve in this massive cities, like where I'm from,
Where
it's
is the-
continuous, Mexico City.
Oh, Mexico City.
It will stop whenever, wherever, it might change route, right? It's a different
Yes,
kind
absolutely.
of,
I would say that continuous approximation could give you an initial idea of the basic structure of the network. How it's going to be a hub and spoke, or if it's going to be a grid line or a mix of them, but it does not give you precise results because the demand is not so well qualified in terms of people that are traveling from where to where.
for a study, having both would give
Yes.
useful,
Absolutely.
combinable.
Yes.
You get coordinates. In the continuous approximation, you get coordinates for the stops. But the coordinate may
Yes.
not be real.
So it's going to be approximate. In this case, this bus route to stop. Sorry to interrupt. They stop whenever there is a person raising their hand. They would stop. There are no assigned bus stops.
No,
That
No.
just- it
you
just
assume that
doesn't-
the demand is there. You don't know
Yes.
who is getting on the bus.
Yes.
You need to serve demand.
Certain exactly. So by population.
Yes, but it's not correct to say that you just wave your hand for the bus and the bus is gonna stop everywhere. This is different. What you're saying is some sort of demand responsive transit. It's a kind of Uber pool thing in which people will, get the app, and oh, pick me up here and take me to my home. So the vehicle can stop anywhere. Okay, you're familiar with the concept of demand responsive transit. Imagine that there's not a V line here in coming to West Village. I have a bus that will take an itinerary depending on where people want to go. So it may skip some roads and etc. It doesn't make sense here, but it might be this way.
I don't know if it happens in Brazil, if there's any study, or if it's been worth doing, that copies reality in the sense that people will be motivated to pick up as many people and go as fast as possible to get more income, which means they will stop maybe at every block to beat the route coming behind them. Like, this is how
I have not seen any academic study on that. The problem on a bus that will stop on every corner is that this bus or this route is gonna be very slow. Have you ever traveled in New York, let's say, from Central Park to Battery Park? You know what Battery Park is? Where you take the ferry to the Statue of Liberty. Okay? Have you ever done this? I have, with my dear wife. And it almost caused us a divorce. And why is that? Because on our way to Battery Park, I said, darling, let's take the subway. It's faster. And we took the subway in New York, and not the local line. We took the one that stops every 2 stops. On our way back, it was her first visit in New York. I said, darling, the subway is very boring. We are only seeing dark tunnels. So why don't we take a bus? So our itinerary on our way to the Battery Park that took us 25 minutes, on our way back, took us 1 hour and a half. Because the bus stops every 2 corners.
But you were together.
We were together, yes, and we were enjoying the view. It's New York. It was a very beautiful time of the year, etc. But every 2 blocks, and sometimes when the bus leaves the bus stop, guess what happens? The traffic light gets red. Then it stops there. When the traffic light is green, then it gets red. So it's very late. I have a slide, if you want, I can show you later, that compares official data from New York Transit Authority that compares subway with buses. So you cannot stop. In BRTs, stops are usually half a mile apart or a little longer.
So academia will always suggest policy and operators to say, can you please have respect your stops for efficiency?
Yes.
Yes. I know the pushback, but that would be always like the pushback.
Okay. Yeah. So basically, these are how we check the solutions. Nodes must be unique. Each node must be served by at least 1 route. All the pairs must be connected and up to 2 transfers. Okay. How we generate a route? I always say route, but I think I should try to correct myself and say route, because the origin of the word is French, as I learned. So I make this mistake sometimes. I hope to apologize. So how you select a good candidate set of routes? Okay. In order to start the genetic algorithm, okay, and also what we do, we generate on an heuristic procedure. So for every OD pair, we select the shortest path. And we also select all paths whose travel times are within 20% of this mean shortest path. These are the candidate routes, that the ones that we are gonna use to select the best one. The genetic algorithm is gonna use to select the best one. Okay? So how do we do that? We have developed, with a PhD student, we have developed a very intelligent way of doing it. We're starting by selecting isolated nodes. Can you identify 2 isolated nodes here? There are 2 in my network.
1 and 9.
1 and 9. So from one of them, I select a route that will cover this node. And I will select another that will cover the other. Then I select an OD pair in one of the nodes that are not visited by these two routes. So these are the candidate nodes, and I will select this pair and a route here, connecting them. Then I will repeat this until all nodes are covered. If no routes found, I select another OD pair. So another OD pair, and I have another route. Okay? So computational experiments on our algorithm. We used a very traditional benchmark network, which is a group of cities. It's not a city, it's not an urban setting. A group of cities, 15 nodes, 12 arcs. Okay? These are the parameters of the buses, and these are the parameters of the GA algorithm. Spoiler, you know what spoiler means? Something that I'm anticipating what I'm saying later. Spoiler, come on guys, is this a typical bus route network? No, it's not. So the science must improve in the sense that we have to select more realistic benchmark instances to solve this problem. Okay? These are the OD pairs, and these are some of the results that we have obtained. First thing that you could notice, as the number of buses increase, different solutions from our genetic algorithm, the user costs decrease. Okay? So for the largest number of buses, you have the smallest user costs. For the minimal number of buses, you have the higher the higher user costs. And as well, the amount of direct trips. Of course, if I have less buses, I will not be able to provide as many direct trips as you increase the number of buses. You can see the same happening with the 1 and 2 transfers, the headways, and etc. Okay, these are some of the solutions. You know, these are all the solutions that are generated by our genetic algorithm. And this allows us to identify a Pareto frontier in the sense that we don't have one single solution. That's one of the reasons why population-based heuristics are used. Why? Because I have different solutions depending on what I want. What's the maximum cost that I'm allowed to accept for the system, or what's the minimum fleet? Okay? So basically, what you can see, and these are some of the previous results. We have a paper that has many citations, hundreds of citations on this problem. Why is that? Because we could really improve the results on previous results. Let's consider these results with 8 routes. The number of buses is 80, and this is the cost. You can see that we can do with the same user costs with 5 less buses. Okay. Another comparisons of the benchmarks with the literature, as you can see, for different number of routes, okay, you can see that in our case, we require much less buses in our approach than previous results in the literature, and the user costs are lower as well. Okay. Well, other analyses that were performed that were not usual, and they're not very usual. No symmetrical demand. This benchmark instance is the one that demand is the same in the 2 different directions, from A to B and from B to A, okay? And no symmetrical travel times. Now comes the important questions for you. First of all, when to design a new transit network? I mean, a greenfield, a clean slate network. I want you to tell me, when should I design a new bus network? There's a question for you.
It's always an add-on.
Yes.
If there are major changes to the OD pattern, maybe.
But major changes, they do not take place instantly or immediately.
Right, that's true.
I will tell you, I will give you an example. If you don't have any bus network, for instance, in the city of São Paulo, 22 million in Brazil, we did not have a night network, bus network. So people who left job after midnight, they would have to walk hours to get home. So we implemented a bus network, night bus network, to allow people who had to work during the night to come back home or to get to work. This is a good idea. Otherwise, what's gonna happen if you just erase your network and start with a new, brand new optimized bus network?
Wasn't that like Chile's case?
Sorry.
When they changed from like kind of the regulated service to like the new system integrated with buses, but they did it one day. Like
Yes, but,
and they created a big problem for the people because nobody knew where the routes were going, where the names were.
Exactly. Are you, as experts on the topic, are you going to advise, authorities to change the entire network? No, you're not going to do that. Why you're not going to do that? It's not very usual because they have systems that have evolved over time. So this will cause a great deal of confusion. Imagine that starting on Sunday, V-Bus does not run into these roads. You have sent emails, you have texts, people SMS and etc. But people don't care. People are used. I'm used to live here. I know that the bus stops right there, whereas the bus is there boarding people. I know that it runs every half an hour. I know the times. I don't care. So it causes a lot of confusion. I have some hidden slides, if you want me to show, that show some headlines from news showing the mess when you change a significant part of the network, because people are used to that. People follow routines. They know the times, the bus stops, the itineraries. They are not worried about that. Okay. So another question for this audience. Well, just let me finish this phrase. How do you do the transition to electric vehicles? What changes are required for you to adopt? Are you need to change the routes because of charging opportunities? The number of miles the vehicle will be allowed to run every day. What vehicles are you removing from service to be recharged? Take into account that not every city has a regular service that runs buses with the same frequency the whole day, as it happens here in Davis or in Sacramento. So, Gil, please.
Actually, not on Davis, on the first comment. I think that this is a very conservative approach to be worried about the people on the bus. That is part of the diminishing use of transit for the last 60 years. Because we always worried about the people that on the bus, and we never check the people that already gave up or never use it, and we can only lose more people but not gain much. While restarting is about the entire population and not just about the few that still left on our buses. So I think that sometimes restarting is very brave and risky, and takes time for sure, because the usual riders are not happy. But if we keep only looking at the people on the bus, we can only keep losing customers.
Welcome to the United States.
I agree with you. Have you heard of an experience of a new bus system in Boston called Bridge? BRIDJ. Have you heard of it? It's a kind of demand responsive service that would connect central Boston with the neighborhoods, different neighborhoods. And their plan was that our routes are going to evolve with demand. okay? They did not succeed, I must tell you. If you'd ask me, I would have a lot of reasons why it did not success. I agree with you, we cannot be traditional. What I think is important to say is that you cannot think of change the entire system simultaneously. You can do it on a way that you change it, progressively, the parts from parts. I agree with you, because bus routes do not serve the needs of people that are not riding buses. Okay, perfect. Thank you. So, additional takeaways from scientific point of view. Solution algorithm. Why do we have to consider candidate roads? Why do you have to use genetic algorithms? For those small-sized instances, it's okay. Okay, it's good, works well. But for real-world, instance, I'm not sure that genetic algorithm would be the best solution. Genetic algorithms are good, but they tend to be somehow slow in terms of running times. Okay, you're not doing this every day, but anyway, they are slow in general. Also, benchmark instances, as I had spoiled before. Yes?
What happens if you start the algorithm with existing routes as the best choice?
I think this is a good idea, okay? This is a very good idea. But if you're doing that, why using a genetic algorithm? Why not using an heuristic in which you start with your current solution and you make improvements? What would be an improvement of 20% of the network that will get you the best level of service improvement for the riders and reducing costs? Yes, absolutely. So local search heuristics, very clever ones. Tabu search is quite old nowadays. Variable neighborhood search, adaptive neighborhood, large neighborhood search, etc. They cannot be used in the context that you asked me. Also, how do you integrate this with timetable, vehicle, and crew scheduling? This is a whole problem. You have to optimize the number of vehicles, the crews, because they imply costs. Okay, how do you consider stochasticity, robust solutions? Okay, how do you consider electric buses, electrification of the fleet? From the practical point of view, how do you aggregate your input data? Because in big cities, it's not possible for you to consider bus stops probably on a single basis. How do you create traffic zones or traffic areas in which you aggregate demand? How do you consider the road network? Not all roads are suitable for transit with travel. Let me see what time is this. I'm gonna give you, I may have some time. I'm gonna tell you something. I had a funny story especially for the young people. My first job, when I finished undergrad, I was working in a consulting company in São Paulo that were trying to improve the bus network. At the time, there was no computers, microcomputers. Okay, there was no digital maps or anything. There was no good records of everything. So I was given an assignment to drive on the roads, the city of São Paulo, to identify and catalog all bus stops. Because in some places the bus stops, they had no sign. So I was driving the city for, 1 month, visiting places that I would never visit otherwise, because they are very poor neighborhoods in the outskirts of the city, etc. Sometimes I had to knock on doors to ask the person, oh, is there a bus stop in front of our home? You could never imagine what I heard, people complaining. Everybody wants a bus nearby, but nobody wants a bus traveling on your road and a bus stop in front of our home. Nobody wants. So I think we have to select very well the road network, the roads that are suitable for buses to be running, okay? And also how to estimate demand. The models that we use now are some models, those surveys with interviews, home-based interviews, they are very expensive. We are seeing now cell phone data being used to infer demand in transportation, being more and more used, okay? So this I have already covered, when to perform and how to optimize this, and also how to take into account solutions that are good for both for peak and off-peak periods. And how to consider a transit network that's kind of multimodal in the sense that the buses are sometimes integrated with subways, with trams, with BRTs, okay? I was telling the other day, I was talking to Professor Zan's student 2 days ago, and I was telling them, when the bus drivers go on strike in cities like São Paulo, what happens to the subway? Is it more crowded? No, it's not. It's less crowded because people cannot get to the subway. They need the bus as their first mile or their last mile. So the subway is a paradise because people nowadays you have Uber, but you have those prices that change. So when bus drivers go on strike, you're gonna pay 3 times what you usually pay. How to address the first mile? Are you gonna use bike? Are you gonna use Uber, Lyft, or something like that? Are we gonna use some sort of demand responsive transit system in order to increase the attractiveness of those systems? Well, and what's the best fleet type and mix? Large buses are good, but they are less frequent. Small buses allows us to run with lower intervals, but they are more expensive because nowadays we still have drivers. And guys, I will tell you something. Davis is a paradise regarding buses. And one of the reasons it's a paradise is because who are the drivers in Davis? Yes, they drive smoothly. In other parts of the world, in other places, even in London, they don't dare to drive that smoothly. I think this is another good opportunity for autonomous vehicles, okay? Because driving buses in urban areas is very boring. You're following the same route, etc. Traffic, you're driving slowly, etc. Okay, this is the paper that we have that describes some of the things that I have presented to you. And I finished by saying something that is unacceptable. What do you see here that is not unacceptable? This is a picture taken by me. I was in a crosswalk on a traffic light on a bus corridor, medium lane bus only. What do you see here? Two buses, one following the other. They are not respecting intervals. So in many places, solutions might be even simpler. You have to have some sort of dispatching system that really works so that you can really ensure interval or frequency. Okay, things like that does not happen. In our campus, I am mad. Sometimes I see 3 buses together, same route. We don't have that much traffic. They would say, oh my goodness, I was stuck in traffic. That's why the other bus was behind me. No, it happens. So we have a lot of practical problems to address. So, concludes my presentation. Thank you.
Questions?
Please. And speak loud because I'm getting old and my hearing is not that serious. Please.
So the example you presented in the city in Sweden is a fairly small network, right? And how were you at that point running into like too much runtime for your genetic algorithm due to the that small network, or is that running fairly efficiently?
I would say that for a larger network, it would require much more time. Okay, we would have to be very careful with the route database creation in order not to create. Probably we will not be applying those for each OD pair. We are going to select all routes, the shortest path, and all within 20% of the shortest path problem. In real world problem, I would say.
So like in circuit design, it's become pretty popular to use graphical deep learning to optimize. Have you considered that approach?
I'm not an expert on this topic, but I would say that if you have some sort of good solutions in which you can identify and rely on, yes. Otherwise, I'm not sure. Let me give you an example from a different problem. Last mile distribution, vehicle routing problem. Are you aware of what Amazon did 2 years ago? A competition that offered $150,000 as the first prize. They wanted to improve their vehicle routing algorithms that provides, how you're going to deliver packages to your homes. So what did they provide? They gave the teams, everybody's a database, a set of good routes, and you had to identify what were the features of that routes that would allow you to design good routes. I would say that if you have good solutions, that would be a wonderful alternative. If you don't, I'm not sure.
So you have a readily executable objective function, so you could generate theoretically many
Yes, correct, true. I agree with you. I think that might be a good approach.
What sorts of population characteristics are considered usually in a model like this? Like, are you considering what a second choice transportation mode might be? Are you considering things like equity and distribution of stops?
I'm not sure if I can understand your question. Could you elaborate a little bit more?
Yeah, just wondering sort of what population characteristics are considered besides just like population density as inputs to the model.
Oh, as inputs to the model. First, I am not assuming in this model, especially optimization, that I'm considering population density. But in demand generation models, you probably have to consider, a lot of different aspects that would influence the decisions of people of using ridership. The typical ones, age, gender, you'd probably consider income, and etc. I don't know if you are talking about this or not. In those things, those are things that had done. OD generation is something that has been done, that had been done previously, priorly to the application of the optimization models.
Gotcha.
Okay, I understand this is a very important point of potential research in which, that's maybe your question, in which the quality of service will affect the OD matrix, in the sense that if you have a better service with less connections, with shortest travel times, more people would be willing to travel. I have not seen this in papers. By the way, this is something that is interesting, might interest you. What I have seen in the literature related to this problem, I have seen problems in which sustainable aspects are being considered in the transit network. So these are the references. I have seen some of them in which you are doing this type of multimodal stuff that I mentioned to you. So shared bikes, shared autonomous vehicles, demand responsive services, underground design with public transportation. And I have also seen something that considers link capacities, passenger crowding, which is related to what you're saying. You know, if it's too crowded, I'm not taking the bus, I'm not taking the subway. In some developing countries, I say that in peak hours, you cannot have something on your knee and doing some itching. Because if you raise your foot or your leg, you won't find room for your foot back on the floor because it's so congested. 9 passengers per square meter. It's really very congested. Those people that come from developing countries know what I'm saying. Right, the two of you are laughing here, okay? Congested common lines. So these are some of the things, very recent research you see, 2022, 2020, in the literature that are addressing other problems. Okay?
Two questions. The first is, how do you still have an equal view of a complex, more realistic system if you do gradual improvement to the transit system? There might be impacts to others. They're like, oh, this is great, let's do this, and then get in the way of the others.
That's another very good question. I would say that maybe you can consider a system, global system-based optimization. It doesn't mean that you're going to implement everything simultaneously. So if I would be doing optimization, I would consider the whole system, as you're saying, but I would say, where should we start? So you change it gradually, possibly by region, possibly by some sort of lines, the feeders of the, the trunk lines or something like that.
And like I thought of critical path methodology for the project, like something that if you do that, then you can't do this other thing.
I don't see this.
Okay.
Okay. Oh, and let me tell you one other interesting thing related to the network, the night network, bus network that we implemented in São Paulo. We have some routes, night routes, that were replacing the subway. Because most subways cannot operate 24 hours a day. New York can do that because they have 2 lines. So one is not operating during the night, the other is operating. But most of them you require maintenance. And so we have developed, the city developed and proposed some routes connecting major train stations. And there were no similar routes during the day. It ended up that those routes nobody knew about them. Nobody were riding despite being very attractive during the day because they were connected to major subway stations, because nobody was aware of them. So it's not everybody that's, oh, what's the route that I'm going to take today to go back home? People are used to it. So Gil, that your question, people are used to do it and they are not optimizing their routes on a daily basis. So there is an important matter related to any changes that you make is to inform people, properly inform people. And this is not an easy task. I don't know how to do it.
Actually, there's a very successful one, and this is 20 years old, like the Buos in Madrid, like always, and they're different routes, and they're very successful in terms of like safety, and it's just 9 different routes. My second question, and do you feel comfortable sharing your presentation?
Absolutely not. Absolutely, yes, I'm sharing. I don't mind, sorry. Okay.
Thank you. So which software would you recommend to, like which one do you like to use for these things? Like maybe for like the ones that are usually more traditional, which ones have you used then?
You know, for what part of the problem? For optimization, when you are dealing with heuristics, it's a sort of tailor-made thing. You don't use any software. If you are doing optimization, exact methods, you have Gurobi. Some people would prefer, Gurobi. Some people would like Ciplex, which now belongs to IBM, and etc. These are the main engines for optimization problems in linear integer. When you are dealing with heuristics, something that's, it's more, each application has a different software. And my experience with this is that sometimes it takes longer for you to adapt someone's code than to start from scratch doing what exactly you need. I have this experience. There's a lot of codes in GitHub, etc. available. Sometimes it's so difficult to understand. Please.
So you mentioned infrastructure early on. Do you have any examples or cases where the problem you were trying to solve was something like, we have this much money to widen a road or improve a road, and which one of these links should we improve? And then you take into account how you would alter that.
And what type of improvement as well?
Yeah, one idea would be that you could improve the performance of the bus system by improving the infrastructure, and you're trying to figure out what's the best way to improve the infrastructure to get improvement in the bus system.
I think this is a very good question. I have not seen this being addressed in academia, from a scientific point of view, and I have not seen this being addressed in practice in general. Decisions are made on a much simpler way. I want to do this because of that, because I am someone that understands everything. There is another thing. So,
well, I was just going to say that of course, most of the time, if you're going to improve roads, everyone cares about how it affects the drivers, right? And they don't maybe think about what it will do to the bus system. So I don't know.
Here, I would say that happens here, but that depends on the mode priorities that the city has, because that wasn't the way that they would do it when they did the BRT in Colombia. Like, it was like, we're gonna improve the bus route first.
Well, that's the question I was asking.
Yeah,
Right,
but
right.
I guess it depends on the priority that the government has for the mode. So for
Well,
us,
who drives cars?
Huh?
I said, who drives cars?
You.
The rich people drive cars.
Yeah, no, but we
Okay.
only have 15% of people driving cars.
Yeah, but they're the rich 15%, right?
Yeah, but still, when they did the BRT, they said, okay, we had 4 lanes going, it was like 3 lanes for each direction, and then they decided to do something like that. Take 1 complete lane only for buses, do that one in concrete and well done, and then they did the other 2 just like a simple repavement.
And I would like to mention another important practical point. And those pictures show this in the city of São Paulo. What do you see here? This is not exactly a BRT, but it's a median lane dedicated bus lanes. What do you see? Would you live here? In this, one of those buildings? No. This is one of the wealthiest areas in the city of São Paulo. But where are the wealthy buildings? They are 1 block away. Why? Because they have decided to implement a dedicated bus lane, median here. The lanes for the traffic are very narrow. It's less than 10 feet, I would say 9 feet or that. So what happens? This area is very deteriorated. You see the sidewalks. If you are not very certain that you can walk in the straight line, you may be very careful because you're going to be hit by a car. Okay, run over. See here, another place in which you have, at this time, curbside lane in São Paulo. Okay, you see here, this house is on sale. It seems to be abandoned. Why? Because this dedicated bus lane, and you have 1 traffic lane for cars. Imagine that, 1 for cars and 1 for buses in peak hours. Nobody wants to live there. Nobody wants to have a store there. So we must be very careful with the decision that we make related to public transport system. You know, Transmillennial is wonderful. You have a wide avenue, several traffic lanes, but sometimes we are implementing things that are deteriorating areas in which the cost of land is very expensive. And that we're wasting very good areas in which more people could live. I know that doesn't answer a question, but you know, it brought my attention that this is something important, okay? You see this again here, all bus lanes in very narrow roads. So you must be very careful because people don't want to live, don't want to have their businesses there.
I have a question.
Oh, please.
So earlier this year, we published a paper in which we analyzed the case of COVID transit in San Francisco. When the city withdrew some bus lanes, we analyzed what people did and how they use bike sharing to basically replace the lack of buses. What is your point of view on the role of new mobility options, not only for reaching the first and last mile, but maybe replace traditional transit services?
That's a very good question, Miguel. I would say that it depends much on local conditions. Let's give you some ideas. Davis is wonderful for biking, except maybe between June and August. Why? It's always sunny, it's not very cold, it doesn't rain much, so you can rely on buses. And Davis is a kind of flat city, you don't have to do a lot of exercise. If you go to Bogota or even to São Paulo, which are very hilly cities, you know, you have to take a shower if you are biking for half an hour and get into work, especially in summertime. So I think it depends on the city, the characteristics, how comfortable are the people to be walking or to be biking, to be using those active modes, or even to use public transport. You know, sometimes if it's too crowded, I would prefer to drive because I don't want to be squeezed by people, you know, touching me, everything, because they are so full of people. I don't know if that's
This is where the e-bikes are interesting though.
Yes.
Because they're not the same thing as regular bikes.
Yes, absolutely.
And they're a big deal in San Francisco. My son lives down in there and they love those because they'll take the hills, you know, I mean, it
But
does
you
okay.
know one problem with e-bikes. I was biking once, I was planning to bike once when I was at MIT. I usually go to MIT Center for Transportation and Logistics at least once a year. Thank goodness I didn't choose to bike from my hotel to MIT. You know why? Because one major problem with bikes, which is
Parking. Yeah.
repositioning.
Oh, I see, yeah.
I wouldn't find any space to, you know, park my bike, to return my bike 1 mile from MIT. I would have to bike back half the way.
The blue bikes.
Sorry?
The blue bikes.
Yes, so one of the, that I see, one of the difficult problems that cities have to address is how to, in our campus, everybody could bike from the subway station, but in the morning, you won't find bikes close to the subway because people got the bikes and came to the campus. And nobody wants to go back to the subway station in the morning because everybody's coming to class.
We need autonomous bikes.
Maybe, yes, autonomous bikes that would bike themselves. I've seen that. I have a movie that shows some autonomous bikes that could bike themselves. Otherwise, it becomes expensive.
Any more questions?
I
We
guess,
have two online.
Yeah, we have 2 questions online.
okay, go ahead.
Someone asks, what role might incorporating comprehensive travel education into our K-12 educational curriculum play in how our transport system develops and is used?
This is a difficult question. I don't know if I'm capable of answering this question. I don't know. I invite you to to say something on that. I don't know. I think that one aspect that we should be always conscious about is that it's obvious there is not enough space in streets for ourselves to drive all the time. Every time you widen your roads, you just attract more traffic. You know, if you are gonna widen the road, the highway to San Francisco, people are gonna say, well, now I'm gonna live in Davis, or I'm gonna live in Fairfield and commute to San Francisco. And then again, it's gonna be congested. So I think this idea that we would love to drive, it's more convenient, door to door, etc. Is something that's not sustainable. It's not sustainable from, an investment point of view. It's not sustainable from an environmental point of view. We cannot afford to do that anymore. So I think this is something that people should learn more. I don't know if to answer this question, I don't know if any of you experts can add something else.
Nice. I do agree with that, and I think that's something that a lot of children could benefit from learning at a young age,
Yes.
especially when they can't drive and are dependent on others to drive to get around. But I mean, integrating it into a public school curriculum seems kind of infeasible just because that's so politicized. I don't know, maybe it could be done, but it would it would have to be done like in a very discreet lesson. I don't think it's this type of thing that could be comprehensive.
Maybe take children to take buses, subways, when they're young, I don't know.
If you want to read a little bit about the topics, Susan Handy did some studies with people who finished Davis and were biking here, but keep biking after leaving years later. I did some studies on immigrants to the US who've come from countries that have good public transit, Europe and other, where they keep using public transit after coming here for a couple of years. And unfortunately, the impact is very low. So the knowledge, the education by itself, it was not enough.
Take the example of Lucas, who was presenting here a couple of weeks ago. He doesn't have a car.
It's take a couple of years.
Yes.
Yeah, that's what we find.
Yes.
Take a couple of years and you become
Anyway,
American.
he has 3 kids and he doesn't drive. When he needs, he rents a car. He's near bike everywhere.
That's the first 6 months.
Just,
But
yes,
I mean,
There's-
translator.
and I was curious about that case. There's 8 BRTs in Mexico City, and there's one that's the largest, that's 140 kilometers. And for that one, it was the opposite. It gave more people. This is 1.3 million users a day.
Wow.
So it's
And
For
it
the
has not
businesses.
degraded the region.
no, like it has businesses, and they're
I
very
see.
happy to get a lot of affluence, like volume of humans walking by and consume.
But probably you have good sidewalks, you have better traffic lanes and etc.
Driving lanes did get smaller, and there was backlash, but there's again the issue of 80% of the people in Mexico City use public transit. 20% are loud and rich, but a minority. So it went through.
In the city of São Paulo, from every 2 people that are not using active modes, are not walking or bike, are using cars. So 50% of all motorized trips are done by cars. We can't afford that. It's more than New York, the city of São Paulo. So imagine every 2 people you are meeting, one of them is driving every day. I drive to my university because if I don't drive, it's gonna take me 3 times in terms of time. If we have to go to central areas, right, darling, we only take subway. We don't drive because parking is expensive. It's gonna take me longer to drive than to take the subway or buses.
Okay, I think we are, well, we can.
There was one other
we
question.
can
Yes,
have-
another one, please.
It's just how can pedestrian access to transit stops be integrated into transit planning?
I think this is another good point. Sometimes transit systems are not designed thinking of the pedestrian. You know, sometimes you have to, to face several obstacles to get to the transit. You have to cross roads, you have to wait for the traffic lights. I sometimes tell my students when I'm back in my country that sometimes I have to wait so long for the traffic lights to cross a road that I can see my hair getting white. Okay, I see wrinkles on my face while I'm waiting. So I think that we should think in a more broad vision, including pedestrians, sidewalks. Bus stops in many different countries are horrible. In my country, in São Paulo, they are horrible sometimes.
Except Curitiba.
But Curitiba is a 2 million, it's a city of whose population is 2 million, and they started in the 70s. One thing is that you built your subway in the beginning of the 20th century, 19 something. Another thing is to build something nowadays for big cities. Remember that many cities in Latin America, Africa, and Asia have increased their size in 50 years by 6. Population of São Paulo multiplied by 6 in 50 years. No city can cope with that. It requires a lot of planning. Possibly Mexico City the same. Rio, São Paulo, Bogotá, and etc. Okay?
Okay, thank you so much.